Okay, welcome back. We're still in Module 3, Topic 1, Lesson 3, Activity 1. 3, Topic 1, Lesson 3, Activity 1, page 373. This is my take 2 of this video, so that's the last one up. Here we go. Habits of mind, model with mathematics, use appropriate tools strategically, take note all tiles that are the same size and have the same value represent like terms, so things that are the same. In an algebraic expression, like terms are two or more terms that have the same variable raised to the same power. The coefficients of the terms can be different. So let's underline this. Like terms are two or more terms that have the same variable raised to the same power. And then maybe on this one, we'll squiggly under it. The coefficients can be different. Let's start our exploration of combining like terms with a review of the properties of arithmetic and algebra that you'll use to combine them. So it says, given the algebra tile model, write an addition expression that highlights the different tiles in the model. Then, if necessary, combine like terms and write the expression using as few terms as possible. Okay, so let's take a look at that. So we have 2 of the x squares, 3 x's, and then 4 of the 1's. So if I were to write that out as it says, I'm going to do it down here. I think I'll have the most room. So I have an x squared plus another x squared plus x plus x plus x, and then 4 of the 1's. 1, 2, 3, 4. But then it says write it using as few terms as possible. So basically, our x squareds are like terms. They both have an x raised to the second power. How many are there? There's 1, 2 of them. So we have 2x squared. The x's are a like term. See, and they look alike. They all look the same. So there's 1, 2, 3. And then we have the 1's, 1, 2, 3, 4. So plus 4. Okay, so it says, number 2, analyze the last expression you wrote in question 1. This. How many terms are in your expression with the fewest terms? Okay, so what they mean by this is they don't want us to say that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. They want us to look at our simplified expression. So how many terms do we have in this? 1, 2, 3. So we have 3 terms. How do the terms relate to the algebra model? Well, the model shows 3 different sizes of tiles, and we have 3 terms. What is the greatest exponent in the expression? So the greatest exponent is 2. We have a 2x squared. What is the coefficient of x in the expression? How does this relate to your algebra tile model? Now you have to be careful. It's not x squared. That's different. Here is the x. So the coefficient of it, remember, is the number that's being multiplied by the variable. So the coefficient is 3. And how does it relate? Well, there are 3x tiles. Okay, you can pause if you need to. I'm going to flip it and keep going. Consider the model. X, y squared, x, y squared, y squared. It says write an addition expression that highlights the different tiles in the model. Okay, so we have x squared, I'm sorry, y squareds and x's. So if we were to just write it out, we have, I'm just going to write it kind of in order here. We have x plus a y squared plus x plus another x plus y squared plus y squared. Okay, so now it says rearrange the tiles to combine all of the like tiles. How many terms does your expression now have? So let's see, we have x's and we have y squares. So here's 1, 2, 3, 4, 5 of the x's and y squares. There's 1, 2, 3 of those. I'm going to put that in front, 3y squared plus 5x. We generally put expressions in order from highest exponent to lowest. Okay, so how many terms does it now have? Well, I guess it has 2 terms. That's our answer here. Write the new algebraic expression. We just did that. Okay, so I guess for here, the 2 terms, we could just look at this and say, how many different shapes are there? There's the y squared shape and there's the x shape. So there's how we can get 2 terms without even looking at the expression. Take note, combining like terms means to add or subtract terms with the same variables, such as 3x plus 5x. These terms combine to make 8x. Number 4, represent the algebraic expression 3x squared plus x plus 2 using algebra tiles and sketch your model. How many types of tiles are needed? Well, we have an x squared, so that's one type of tile. We have just an x, that's another tile. And then we have just numbers, so we need 3 different tiles. So our x squared are going to be the red side here. Your book has them pictured as green, but these tiles here come red. So we have 3 of the x squareds, the x, so we'll do the long one for the x, and then now they're using these small ones for the numbers. So plus 2. Okay, so sketch your model. So we have x squared, x squared, x squared. We have an x, a 1, and a 1. How many types of tiles are needed? 3 types of tiles are needed. Okay, moving on. Slide these off here. You can also use algebra tiles to represent multiplication, the worked example. So it says, you know what, we're going to pause right there. We're going to pick this up in the next video because this page and the next page are kind of lengthy and about multiplication. So we're going to stop there for now.